Yes.
Distance between the plate, the length of the plate, and that's the width. So we need to write an expression for the capacitor. Area is L times W. Done. Part B, you need to draw the electric field. Okay, if you notice, for this part, here's an electron, it's negative, and it's going this way.
Yeah.
What that means, if it's going that way, there's a velocity coming in right there, and it's pulled this way. That means this plate has to be positive. Negative. So the electric field electric field. That's part B. Part C. Since the electron is going this way, it's a parabola, by the way. You notice that's a parabola?
Yeah.
It's a parabola.
Half of a parabola. So that means that the force has to be pointing this way. That's the electric force. Pulling the electron up that way. See, it's moving, but it's going up that way. It's pulling it up. That's part C. Part D, we need an expression for the electric field. Electric field is equal to force over a charge. It's the Coulomb force. The mass times the acceleration divided by the charge on the electron, perhaps. Okay? So we need an expression for this acceleration. Now, since we have parabolic motion, what we know is that from here to here, that's d over 2. Because it said it's midway in this thing. That's d. So that must be d over 2. And from here to the end is L over 2. It's midway. So if we go back to our kinematic equations for what do you call it? Projectile motion. Here's one of them for the y component. Y minus y. Y final minus y initial V0y times t 1/2 a t squared. Let's look at that one. Okay, if this thing is traveling this way, parabolic path, y final minus y initial is going to be d over 2, right there.
Yeah.
All right? The initial y is going to be 0. There is no y component here. So that's 0. Plus 1/2 a t squared.
T squared.
I'm trying to get an expression for this a right there.
Yeah.
Because your answer for this problem must be in terms of L, D, M, E, and V0. There cannot be any A. So we got to get an expression for A. So based upon this, okay, A is going to be D over T squared. Which means I need an expression for my time as well. How much time does it take for this electron to travel from here to there?
Sounds like another kinematic equation.
Well, we can use the x component now. Remember the other kinematic equation, V, delta x equals V0x times t. All right? That's another equation for the projectile motion. We're looking at the horizontal motion now. Now, what is delta x? It's L over 2. What is V0x? It's V0. And what is t? T is t.